electric potential due to continuous charge distribution. So first, we have define electric potential as electric potential energy per charge. Okay, so potential energy was defined as the capacity of an object to do work. So suppose we have volume charge density P and its superposition vector is R. Okay, laging tandaan ang density is P ang nagano ng liter. Then to calculate the electric potential at point P due to the continuous distribution of charge, entire charge distribution is integrated. So we have the given below the vector and the R. So where we have P volume charge density, dt small volume element, R position vector at point P, R position vector at dt. So next, unfairly charged spherical shell. Point lying outside the spherical shell. Here, point is lying outside the unfairly charged spherical shell at the radius is greater than R. Hence, electric potential is vector. So we have the given. Okay, electric field outside the uniformly charged spherical shell is equal to the electric field generated by the shell as the shell is concentrated at the center. So first, we have point lying inside the spherical shell. Here, point is lying inside the spherical shell and hence the radius smaller than R. And the electric potential is vector. Same pa rin po. Kaso lang po, ang sa given po natin, ang pinagkaiba lang kanina po, small liter yung sa may uniformly charged spherical shell. And sa point lying natin naman, yung sa itaas niya, yung Q. And sa R, big liter na yung R nga sa point lying. Okay? So, we have next. Like in the electric field intensity, we have 3 different formulas for each type of charge distribution. So, we have 3 different formulas. The line charge distribution, where P is the line charge density. And the second is surface charge distribution, where P is the surface charge density. And the third is volume charge distribution. Okay, thus, nakikita nyo naman yung mga given. Lagi nyo lang tandaan yung pinagkaiba. And next, we have find the electric potential on the xy plane due to the pair of charge, one of charge, positive Q, at solution, and the other of charge. We define a point P to be at some unspecified position. So, this is the example and check work against my solution which follow the problem statement. Okay, it's very important to us to be able to contrast the electric potential with the electric field. So, kung nakikita nyo naman yung mga line, ayan lang yan, madali lang yan naman. Pagguguhitin yung P and X and Y sa taas. And next, so the next is, we call the distance from positive charge to point P R positive, and we call the distance from the negative charge to point P R negative. The electric potential due to a single point charge is given by kilogram divided by R. Also, the contribution to the electric potential at one point in space due to more than one point charge, simply and add like numbers. So we have the numbering here and the diagram. Kung nakikita nyo naman ang pinagkaiba, di ba? X, P, Y, Q, and we can determine with that. So, we have next diagram. So, we can see that the number plugging both of these result into our expression, right? So, in this formula in mind, as we move on to the new step, also keep in mind the fact that various contribution to the electric potential at empty point in space, simply add like numbers, colors, rather than like vectors, okay? So, we are dealing with some line segment of chart. It can be anywhere and any orientation, but for concretes, let's consider a line segment of charge on the x-axis says from x a to x beware. Okay, so we have y positive q. Natatandaan nyo ang vector. And the position, we have the idea is to treat the charge distribution as an infinite set of point charge, where each point charge may have different charge value depending on where at what value m is along the line segment. So this is the topic that I discussed, and this is the electric potential at point P due to the charge line segment on the X. Each bit of charge on the line segment is specified by its position variable, thus summing the contribution to the electric potential due to each bit charge. Okay, kung nakita nyo D and 2, magano lang, slide to X and Y and P. So, that's the finish of our discussion for today. And I hope you listening for my discussion. In the next chapter, we explore the fact that if you know the electric potential throughout a region in space, you can use that knowledge to determine the electric field in that region of space. Okay? Our purpose of this chapter is to help you develop your ability to determine the electric potential as a function of position and the vicinity of charge distribution, in particular, and continuous charge distribution. Recall that you think of continuous charge distribution as some charge as emerges over space. So that's all for today. Thank you for listening. I am Maril Joy Bangcaya again. Thank you and